All right. Welcome, technical session T-11, power supplies. Just a gentle reminder that we do a lot of these technical sessions out of order because we were trying to match up all the material together so that you're getting double coverage on everything that we're going over on a given time. So through today, we're going to be talking about characteristics of power supplies and the connectors involved as well. Be able to select a power supply based on given specifications, describe how to remove and install a power supply, and identify common problems that come up with power supplies as well and how to address them. Our BSMs for this particular cohort or this technical session are communication and working in a team environment, especially if you are working on very complex problems that are going to extend beyond your shift. You may need to hand these problems off to a teammate. You need to be able to effectively communicate what the problem is, where you're at in the troubleshooting and problem solving process, what the customer's expectations on and where you are at, and if any communications need to be followed up with that customer. All that needs to be conveyed to your teammates in a very quick and concise manner. Also, maintaining a growth mindset. Technology is one of those fields that is ever changing. So not sure if many of you thought this when you stepped into this particular path, but when you are on this path, you are continually learning and growing. That is how we have to stay up to date and ahead so we are able to solve any problems we can see coming down the road. Now, understanding electricity. We briefly touched on this in the intro to computers. Now, electricity in and of itself is a flow of negatively charged particles called electrons. The pressure, how they are being pushed through, is measured in voltage or volts. And then the amount of electricity that is moving through the wire, it's called current, and we measure this in amps. So the voltage is the pressure, the amount of water moving through is amps, and say the diameter of the pipe would be wattage. If you are thinking of this analogy as electrons like flowing like water through a pipe. And wattage, easily calculated by volts times amps. That gives you your wattage. Now, amps is something you definitely pay attention to because that also is a good indicator of danger, because you can, I think it was expressed to me that you can swim in an ocean of voltage, but just 1 or 2 amps can kill you. So you need to pay attention to the amperage when working with electricity as well. Now, wires themselves provide resistance to the flow of electronics or electrons through the wires themselves, and that is measured in ohms. You do not specifically need to know all this. This is just basically an overview of basic electricity so that you kind of understand where some of the numbers come from when you are looking at specifications and needs for your equipment. 2 different ways which electricity flows. You have single direction or unidirection, which is direct current. And most electronics devices require direct current to be able to flow. And in order for this to be capable, a lot of times plugs and stuff like that utilize power converters to convert that power from alternating current, which is how it comes out of the receptacles in the wall, into direct current. So it is a much more usable service for our electronics. Now, alternating current oscillates between negative and positive voltage. And it goes from the power station to the, I think, the transformer at your pole, and then the transformer turns it to direct, which comes to your house, and then it gets changed again to alternating. In the US, our voltages operate off of between 110 and 120. typically notated as 115 VAC, although commonly referred to as 110. Outside of the US, South America, Africa, Asia, Europe tend to operate off of 220. This is important to know when dealing with power supplies because the power supplies operate off of different voltages as they are coming in from the walls. Older power supplies, you actually have a selector switch that you need to determine whether or not you're operating off of 220 or 110. If you select this improperly, if you go to Europe with a US-based computer and you have it set on 110, you plug it in and you turn it on, the voltage will be too much and you can fry your computers essentially, or cause damage at the very least. Now, if somebody from, South America comes here, their selector's set for 220, they plug it into US receptacle, which is 110, they try to turn it on, there won't be enough juice for the power supply to actually run. So it's a little bit more forgiving coming to the US with a 220, less forgiving if you're going from the US to another country and you don't select it off of 110. Thankfully, most modern power supplies today auto select between the two. So it may be set automatically for 110. If it receives more juice, it'll automatically kick over to 220 and save the unit and still be able to function. You will not know this is happening. It just is done internally. So the selector switch is kind of going by the wayside for an automatic selection. Questions so far?
So you're telling me that Europe has a higher voltage, meaning they have like a stronger amount of like electricity?
It is a higher voltage standard that they operate off of. So the electronics that they're using over there are set for a 220 power source rather than a 110.
You could fry your computer or whatever, right? You're using if you like just plug it into that.
Yeah, if it does not have an auto select and you go ahead and you plug it in and you have it set for 110 and you plug it into 220, you can damage components, you can fry the computer, a lot of bad stuff can happen. If they come over here and they don't select it down to 110, it may not have enough juice to even turn on. Yes, Renzi.
Those power things that you get to adapt the power adapters, does that then prevent that from happening?
Depends on the power adapter. Some are literally just a plug conversion kit where it will, you literally put it on the end of a plug and it'll take it from, say, like in Italy, they use the dual post or the 3-post plug. You can have them where you literally just plug it in. There's no electronics in it. It's just converting it from our 2-blade plug to their 2 single-post plug. But there are converters that will automatically switch it down from the 220 to 110 so you won't fry any of our electronics. So, that's where you would read the actual specifications of the adapter you're buying. So, all right. Yes, Janina, did you have a question?
I did. I just wanted to know that, like more modern computers that are recently coming out, would they have that automatic on and off switch? I'm sorry.
Yes, more modern, like coming out in like the last couple of years, they are leaning more towards that. The selector switch on the back of the power supply is kind of going away, and it's becoming an automatic select where the internal sensors on it, as soon as you plug it in, it's like, okay, I'm getting 220, flip to 220. Or somebody comes over here and it's like, I'm not getting 220. It feels like I'm getting 110. All right. And they switch over to 110. So it's becoming more of an auto select. With regards to the exam, it's still a selector switch and something you will likely run into in the wild because offices don't necessarily update their equipment every year or two. So, but just be aware as things are being replaced, it's becoming more of an automatic thing. Did you still have a question, Renzi, or are you good? All right, excellent. Okay, now, basic purpose of the power supply, or the PSU, is to supply power to all components within your computer. And it also converts the power from alternating current to direct current, so that it is a usable source for the components within your machine. We already talked about the selector switch and the automatic switching that is coming. I hate that they do this. So let me separate that out. They always do that. So there are the voltages that we had mentioned prior that are viable for all components within the PC, from in the PC. You have the plus 3.3, you have the plus or minus 5, and the plus or minus 12. Those are the 5 voltages that are utilized within the system. Power supply also, you see this nice little fun bundle of wires here. Let's see here. Yes, Jimmy.
Just quick question. What is VAC and VDC again?
Voltage direct current.
And
VAC would be voltage alternating current.
Okay, thanks.
Sorry, I should have notated that. All right, so right here coming out of the power supply, big fat bundle of wires. Each of these, on these wires, you have these fun connectors, which hook up to all your components in your PC to supply them with the power that they need. Some of them will derive power directly from the motherboard itself. Others may need a direct connection to the power supply to get the juice they need to function. Like hard drives, optical drives, things like that. Sometimes graphics cards need actual direct power hooked up to them. Oftentimes, you also have a separate connector on the motherboard for CPU power. And then you have also direct connections to the motherboard for the front panel connectors. So the capacity for your power supply is measured in wattage, watts. Did you still have another question, Jimmy, or?
No, I'm good. Sorry.
All right. There we go. Clear. There we go. Okay. So basically inside of a power supply, what it looks like, you have power coming in, it does a conversion from AC to DC, then it starts splitting everything out on the various voltages that is required. And then say, here is your 20-pin connector. Now, each of they're what they're called as rails. Each of these rails will operate off of 12 volts. More modern PCs need a lot more juice than say PCs 10 years ago, with all the fun new components we're adding into it, like upgraded graphics cards and things of that nature. So they will be multi-rail systems where they will have different rails running at 12 voltage and then broken down into smaller components like these 3.3 volts and 5s and what have you, so that you can utilize these systems more effectively. All right, so here is a close-up on that switch right here, this little red switch that you're seeing. Circle in yellow. This here, that is your selector switch to change between 110 and 220. It is a small switch just above where you would actually plug in the cable from, that you would then plug into your power strip or into the wall itself. So just note that that is there, especially when you are doing labs in test out, because that is a toggleable switch in test out. So make sure you are aware of that. It is tiny, but it is there.
I had such an issue with that yesterday.
So the switch itself is there. The other one to pay attention to is this one right here, this on and off. This is a kill switch. It is not the same as pushing the power on the front of your computer, but you can kill the power supply from this on and off switch. Also, bear in mind, this is the switch that got me when I was doing the power supply install. I did not think to look at the back of the computer and turn on the switch there. I just kept hitting the power button and nothing was happening. So I spent 30 minutes troubleshooting that in test out because I couldn't figure out what was going on. Also, be aware there is another power switch next to where the cable goes on the back of your computer. Make sure that is on or your power supply will not function. Yes, Humberto.
Yes. Will you please show which are the rails? I didn't understand that.
The rails is just about the amount of wattage or voltage that's coming out of the power supply itself, because each rail can only handle 12 volts. Older power supplies, everything in that computer could be supplied with enough power under 12 volts. So computers nowadays require a lot more power than that. So you have what they call a multi-rail system, where they have several, like 4, 5, 6, 12-volt rails running through there. It all depends on the power requirements that you need to run the components in your system.
Thank you.
No problem. I mean, it's kind of, it depends on the system, what it is you're going to need. So, you know, we'll get into that here in just a little bit. All right. Any other questions so far? All right. So these are the three pieces you'll see on the back. You have your 3-prong plug that you would plug your cable into. It's called actually called an IEC cable. So if you go to a job and they ask you to go to the room and ask for, you know, hey, grab me a couple of IEC cables, they are likely just testing you on basic knowledge. That is what the power cord itself is called for the computers and monitors themselves, as well, 3-prong plugs. So, and then you have your 110, 220 selector, and then your kill switch as well. All right. We just talked about it. Physical switch to turn on and off the power supply itself is in there. And then we talked about last week, soft power, which is that button in the front that you play, you know, you push the button up there and it allows you to do multiple things. If you press it real quick, it goes into hibernate. You press and hold, it'll kill it. You press it real quick, it'll turn it on. This is called soft power. And even when you do the press and hold, where it's going to do that hard reset, the beautiful thing about the soft power is it immediately communicates with the BIOS on the motherboard and says, hey, you need to stop all functions right now. We're about to kill power. So it allows the system to shut down everything safely, even though it is considered a hard reset. Now, if you just hit that kill switch on the back, that can be more destructive to the system. Or if you unplug it as well, that can be more destructive to the system. The soft power allows it to communicate and just say, hey, we're about to kill everything. All systems need to shut down right now. And this happens really quickly. So that's where that, you know, multi-selection comes in from the power button on the front of the tower. So any questions on that so far? You will likely see at least one question on soft power on the exam, just so you know, for the CompTIA. Yes, Romario.
So when will you utilize the kill switch versus, you know, the just holding the button for soft power and everything?
Last resort.
Last resort, okay.
That would be a last resort, or once everything is shut down, you would do that as just kind of a final safety precaution before you start opening up the system and removing the power supplies and stuff like that. That way, when you plug everything back in, you know, it's just like a nice little buffer as well. So it's just kind of a safety precaution.
Okay, so otherwise we're just leaving this switch alone.
Yeah, for the most part, this is left alone. Once you've installed everything, you turn it on, then you turn your power on, you're good to go. Likely you won't touch it again unless there's an issue with the computer where you need to open it up.
Okay, thank you.
All right. Moving right along, cables and connectors. Definitely need to be familiar with these on site for the most part. So we definitely have the one right here we should all be becoming very familiar with, which is that 20+4 connector, or called the P1 connector, power connector. It's the main power supply for the motherboards. Although many times you will see this +4 can break off or disconnect from it, and then is connected in another location specifically for the CPU. That will also log into the computer, or they may even have a 24 pin and then also have a CPU connector. It depends on the systems you are using. But also, you know, as we talked about earlier, there are only 5 voltages you can receive, +3, ±5, and ±12. And that is all notated by the colors of these wires. Will tell you what voltages are running through them. No, you do not need to know that, but you should be able to read a schematic to know that stuff going forward. But as far as for the exam, not so much. You don't really need to know that. Questions so far? Oh, hold on, we got a visitor. Sorry, he was wanting to come sing to me for some reason. All right, Romario.
Yeah.
Did you still have a question, or are you good?
Oh, I'm good. Sorry about
Kind of hanging out there with your hand up. There you go. All right, we're good. Okay, so 20 +4 pin connector right here, and then obviously our CPU connector here. Need to be very, very familiar with those, seeing those on site. The most the easiest one to identify is that 20 +4 though, because that is going to be your biggest connector when dealing with power supplies. Also, we have our 4-pin Molex, which is this one up top, which is a little bit larger connector. Right here, it is a 5 and 12 volt, typically used for older IDE drives. Obviously, it's going to require a little more effort to snug it up when you're locking it in, because it is going to be one of your larger connectors, kind of like your P1. Then you have a little bit more modern iteration, which is the mini 4-pin connector for optical drives and things along that line. And later 3 3¼ and that supplies 3.5, 12, and 5 variations. All right. Should be familiar with this one now. The SATA up top. It has a slight L shape to it, kind of like your SATA drive connectors that you would see on your motherboards themselves, or on the floppy drives that you would connect down to your motherboards. So this would supply power to hard drives and other drives as well. And typically is almost always a black connector, unlike the Molex and the Mini 4, which for the most part tend to be white connectors themselves, just so you have a little bit of a quick visual reference when working with them. And then down here below, you have the PCIe Express power supply as well, which comes in a 6 and 8 pin variety. And this would typically be used for your higher end video cards that are going to require a little bit more juice than they can get just off of the drive. They also tend to be a black connector themselves. And then you have the modifiable 6 and 8 pins right here. Any questions so far on that? Luis?
Yeah, when we connect it to the motherboard has like initials or writings where to put these cables exactly at. Like, let's say you forget and you're trying to look for the actual right connector port for these cables.
Yes. So on the motherboard, yeah, they do have the writing where you can use that kind of as your map. You also have the documentation, which may also give you a map for where things need to go. But bear in mind, for the most part, I mean, for the exam especially, they will blur it out so you cannot read it. So don't rely specifically on that for the CompTIA. But yes, Luis, you are correct. There is a map on the board where it'll tell you what everything is as you're next to it. Yes, Mark.
Please tell me that will be the pictures on the exam will be bigger than they are in test out. Some of those we can't find those pins.
I think they're modestly sized on there, but you won't be able to zoom. Like I said, you won't be able to zoom in enough to where you can read it as far as like reading what's on the boards themselves. But these simulators you will run into typically won't be hardware simulators like you have in test out, where you're hooking up and unhooking things. They're made to specifically be like, you know, like a multi-select, like, you know, where does the 20 pin go? Where's your PCIe express cards? Where's your RAM banks? Where's your CMOS battery? Where's your USB connector? Stuff like that. So it'll be along those lines, but as you drag your mouse over it, you'll be able to see where you can connect those things. And you just kind of need to have a general geographical knowledge of the motherboards where things go. Does that answer the question?
Yes.
Okay. Yes, Luis.
Yeah, about the exam, like let's say by accident you put the 20 pin by accident to another let's say like a 16 pin by accident. Does it mark you incorrect and you can't put it in the correct place anymore in the exam?
Well, no. Well, here's the thing. You can move your stuff around on these simulations. Like if it's a multi-select, like it's going to have a list of components. It may not show you what those components look like. It'll just have a list of them, say 20 pin power connector, CMOS battery, USB connector. You know, it'll just give you a list of what they are, and you need to point to what they are. So yeah, it will let you put them in the wrong place, but you can move that stuff around up until the point to which you submit your exam. It's not a quick one and done. Like if you accidentally click the wrong one, you're done. No, you're able to move that stuff around. All right. Any other questions? All right. Next. If it'll load. Apparently it's taking a dramatic pause. There we go. All right, so here's a basic idea of a schematic. You should be able to eventually, you know, not necessarily for the CompTIA, but for life, look at these and kind of read that schematic as to what it is. You can see based on the coloring of the wires, like the orange is the +3, blue is -12, blacks are the grounds, whites are -5, red is +5, and yellow is +12. And then they also have, you know, a couple others like the +5 volt standby, things like that. But these colors should, for the most part, remain the same across multiple systems, unless you are dealing with like a gaming PC or something like that, where they're going for aesthetic looks, and then all the sleeves of all the wires are going to be the same color. In that case, you may need a multimeter to determine if you have the right voltage in the right port. So if you're having questions about the pins, a multimeter would be a good way to test it. Questions so far? All right. Form factor. Yes, Chris.
I just had a question on the last slide.
Okay.
On the 24 pin connector, the white, it says reserved. What would that be for?
Could be that they don't have that dedicated to anything as of yet.
Okay.
Like it's future proofing the pin, like the pin out. So, but if you look up here, that white pin is a -5. but it could be that they're holding it there, you know, and allowing it for expansion if they need it. Like this -5 standby. I believe, I got to double check it, but I believe that if you set your computer to wake on LAN, a pulse will be set through the network to that -5 standby and tells your computer to wake up. So that's what that one is for. But I'll confirm in this reserve one, but I think that's what they're doing there. All right, any other questions? Okay, form factor. We talked about this a little bit earlier with regards to motherboards. Form factor is really just a fancy way of saying size and shape. So that applies to things not just motherboards. It applies to power supplies, RAM modules, graphics cards, all that fun stuff. Form factor is the way that they're basically going to express size and shape. So we talked about the ATX on Friday, I believe it was, or Thursday, when we talked about motherboards. And that is your standard desktop motherboard. And then you have the mini and micro ATX. Will require smaller power supplies because they do not have as much of a need for consumption, as well as they do not have the ability to expand as much, add as many peripherals and expansion cards and things like that to these mini and micro ATXs as you do to the main ATX. What do we say was a rough cutoff on expansion slots where you would see, you would know for sure if you were looking at it that it was an ATX and not a micro? Rough count when you're looking at it, what was our kind of our cutoff for ATX and micro?
9.6.
9.6?
No.
I'm just curious how you have 9.6 connectors. When does it become a 0.6 connector?
Oh, never mind. I got it. I thought they were talking about the size of it. I'm sorry.
No, you had the, yeah, you had the measurement of it. So I'm talking about how many expansion cards. So we can look at it just off the top and be like, yep, that's an ATX. Roughly.
Is it
5.
4 and 1?
5.
5, yeah.
Yeah. When you start hitting 5 expansion slots or over, you're almost guaranteed to be on an ATX. Below 5, like 4, 3, 2, 1, you're looking at mini or micro or ITX as well.
Are they multicolored or single colored?
Depends on the manufacturer.
Oh, got you. Okay.
You're talking about the boards themselves, or you're talking about the connectors, or
No, the expansion parts.
Yeah, that tends to depend on the manufacturer more often than not. What color is your PCI? What color is that?
White.
White or cream. What color is your AGP?
Brown.
Brown. PCIe.
Blue.
Blue. Sometimes seen black, but that's typically the color coding that they will use for the most part. But again, it falls down to the manufacturer. All right, rails. We were talking about this a little bit earlier. You have your 3 primary voltage rails. You have your 12, your 5, and your 3. Computers with the advanced CPU and video cards require more power supply or more power than the other ones. So some other rails are added to provide power for those particular items. They typically run in 12-volt rails with OCP, which is overpower protection, which allows you to balance the circuitry and supply the required power for each of the components. Now, today's power supply manufacturers will offer single and multi-rail, so it's going to depend on your needs, which one of these you will select. And I think we will get to that here in the next couple of slides in calculating up your wattage and things like that. So most power supplies have wattage ratings for total maximum output. Now it's kind of like your car. If your car can max out at 120 miles an hour, you aren't necessarily going to drive at 120 miles an hour every time you're going down the road. That is your maximum output that you can get out of that car under optimal conditions. Same thing with the power supply. You do not want to run it at maximum output all the time, because that is going to decrease the lifespan of your unit. Now, the wattage capacities are listed in the documentation, so definitely want to refer to that if you are grabbing a power supply off the shelf to replace one that is already in an existing computer, because you want to be sure you have the requirements from that power supply needed to power the computer that needs the new power supply. And also, if you're doing this to multiple units, you don't want to waste a high-end power supply in a lower end unit. If it doesn't need that power, you don't need 2 to 3 times the wattage that it is capable of being installed into a computer. You want to be able to try to best match the power supply to your needs. Questions so far? All right. Determining wattage capacity. Here is one of those scenarios where you have what CompTIA states versus reality. These tend to diverge a little bit at this point. So when you are trying to determine what kind of power supply you need, what kind of connectors you need to basically go through the components inside your case, add up all of this stuff. What are the wattage requirements for the motherboard itself, the fans you're going to be using, SATA hard drives, optical drives, video cards, and other expansion slots? What are the power requirements you need for all of these things that you're going to be putting in there? You add all of those up. That gives you your power needs for right now. Now, we want to kind of future-proof this stuff a little bit. So with regards to CompTIA, they say you calculate up all your wattage and you add 30%. So that is their safe number. You add up everything that you have, add 30% on top of that. That gives you a little bit of room for expansion and growth, and kind of future proofs yourself a little bit. Because if you only get exactly what you need right now, if you add anything to that computer, your power supply is no longer going to be sufficient. Yes, Humberto.
You also have to consider the watts of the peripherals that you are going to plug.
Yes. So like if you're going to have, speakers, USB microphones, all that fun stuff, you do need to take that into account as well. Yes. Thank you, Humberto. So all of that needs to be taken into play when you're doing it. Now, real life, I would say at least minimum 50% more. Mm-hmm. So real life 50%, with regards to CompTIA, 30%. That's how you're going to future-proof your power supply for, some added growth. Any questions so far? All right. Now, go to the randomizer here. Ash, can you please give us number 1?
It's a PSU 4-pin.
This one right here?
Yeah, this one.
It's a 4-pin? Yes, I didn't hear what else you said.
Yeah, 4-pin power supply.
Okay.
And the 5th one is 20+4 ATX.
Okay. Well, we were only asking for number 1, but we're good here. So PS, okay, there's your PS1. All right. Thank you very much. And number one, wait, we gotta call other people too, Ash.
Oh, okay, okay, sorry.
All right, so the first one here is your 4-pin Molex connector. And then number 5 is your 20+4. Let's see who else we can get here. Jordan, can you tell us what number 2 is, please?
Honestly, I haven't been paying attention. I'm sorry.
That's hurtful.
Is it the 4-pin for the CPU?
It absolutely is, TK. It is the 4-pin for the CPU. So there we go, 4-pin CPU. All right.
I can't barely see that.
It's the 4-pin in a square pattern. So that likely would be your CPU connector. Now, if it was a black connector and had 6 or 8 pins, what would it be? Luis?
An 8-pin?
6 or 8-pin black connector.
6 or 8-pin black connector.
Kind of in a square pattern like this almost. So it'd be 2 rows.
To be honest with you,
You got
I did it on the lab.
You got a gaming PC.
Oh yeah, it's for the GPU then.
There you go. So if it's a 6 or 8-pin, it would probably be for your GPU.
Can I do number 4?
You want to bypass number 3?
Me too.
Come on, what's number 3?
I don't know.
I'm not sure either.
Mr. Ponder, you want to take a guess at number 3?
I'm not sure, honestly. I was hoping you don't skip over me too.
You had your hand up. I had to call on you.
Oh, that was for that was for the that was for the PCIe. If it was black and it had 6 or 8.
Okay. Mark, you want to chime in on number 3?
It looks like the 4-pin mini.
That's number 4.
8-pin?
4 right here. You got a 4-pin mini right here.
Oh, number 3. Huh.
Number 3. How many pins does it have?
6.
8.
6.
PCIe.
No, not on that particular one. PCIe would be 6 and they would be 2 rows. This is a single row of 6. This is going to be an auxiliary power cable used for like older drives, like floppy drives and stuff like that. It is an auxiliary power cable as well. And then we have the 4-pin mini, which is used for newer floppies and magnetic drives, but not the newest. Who wants to take a stab at number 6? I got Evan up here. Evan, you want to tell us what number 6 is? Evan? You want to tell us what number 6 is?
Oh, you said me?
Yep.
Oh, my bad.
Number 6.
Would that be the power to the motherboard?
Well, that'd probably be this one, number 5 right here. That's the power to the motherboard. That's your PS4.
Oh, okay.
So yeah, what's number 6 right here? It's got a slight L shape to it. Hard to see in this particular connection. It's a black connector.
I'm gonna be honest with you. I don't.
You had teammates jumping up and down trying to help you. You want to phone a friend?
Yeah.
You want to call?
Red cable on test out.
That'd be the data version of this.
Yeah, I'm gonna need some help.
All right.
SATA?
There you go, Ash. SATA cable. SATA cable. This is your power for your SATA. Now I know. Cables and connectors are not the most exciting aspect of IT, but it is something we do need to know. Yes, Alan.
I was wondering, me and Jimmy got the same question. Can you go over 3 and 4 one more time? So you said number 3 was the aux or audio, or what was it? Auxiliary?
Yeah, 3 is the 6-pin auxiliary. 4 is the 4-pin mini for floppy drives.
So we won't see these two. Well, we will see them in a while, but they're not like common in today's computers.
Mostly they're converting over to the SATAs for their drives. Overwhelmingly, that is what you will see, but there may be cases where you will see the 4-pin and you will see the 6-pin auxiliary. I have even seen PATA cables rather than SATA, which is PATA, which is it's a flat ribbon. I've seen those recently, so they are there. So we do need to be aware of these things, just, in case we come across them, but for the most part, they are moving towards the SATA power drives. 2 is the CPU power supply. Now, if it was for the PCIe, that would be a 6 or 8-pin connector, but it would still have this square shape like this one is. All right. Any other questions? All right. There are answers.
May go back for 1 second.
Go back for 1 second. There we go.